Okay, so we're doing applications of conditional probabilities, tree applications. We're going to specifically look, so I'm going to kind of mix it together. It's what we did in 7.5 with the new type of question that I can now ask using Bayes' formula. Where if I ask you, given the end result of the tree, what's the probability one of the first events was the one that got me to that end result? Since on the quiz they'll be mixed together that way, I'm going to mix them in the problem. So we'll set up one tree, and I'll typically ask you 2 to 3 questions on that one tree. Alright, so it'll usually be a multi-question, multi-part question when we have trees in the quiz. Alright, so the first example, we have we have 2 boxes. They contain marbles. The first box contains 5 blue, 3 red. The second box contains 2 blue and 3 red. Alright, so the 2 boxes have a different set of marbles. We select a box at random, and then a marble is chosen. So there's 2 things that we're doing in this experiment. We're picking a box first, as the first events, box 1 or box 2. And then, once we've picked a box, we pick a marble out of it, and it can either be blue or red, but it depends on which box I have, the odds of getting a blue or the odds of getting a red. Alright, so the first thing we do is pick a box. And then we pick a marble. A single marble, so it's not a combination type. It's just, we're just selecting one marble. Alright, so it's one pick. And then all my outcomes. So there's 2 options, so I'm just going to write 1 for box 1, 2 for box 2. Alright, so if I've got box 1, I could select a blue or a red marble. If I've got box 2, I can also select a blue or a red marble. And then all of my outcomes. So probability it's box 1 and blue. Probability it's box 1 and red. Probability it's 2 and blue. Probability it's 2 and red. I left the ands out there just to make it shorter, but that's what I mean. Now, this means I've picked 1 and got a blue marble. I've picked 1 and got a red marble. I picked 2 blue marble, 2 and a red marble. Alright, then I fill out my tree based on my numbers. So these I actually have to find the probabilities. They weren't given to me. Alright, but they are based on the condition which box I select. So the first option is picking a box. Well, I've got box 1 or box 2, and so there's it's like flipping a coin, right? I've got a 1 in 2 chance of getting box 1, so I've got a 50% chance of getting box 1, so 0.5, and I've also got a 50% chance of getting box 2, so 0.5 for both of those. All right, then remember, these are the conditionals. Given what box, alright, the given part is what box you picked, there's the odds of getting red and the odds of getting blue, but it depends on which box you have, so I've done the first thing already. I've selected a box, and then there's the odds of getting red and blue. So these are the conditionals based on which box I've selected first. So this set of branches is, if I've picked box 1, so given box 1 is in my hand, what's the probability I get a blue? Well, if I've got box 1, right, so the first box, I've got a chance of getting a blue marble. Well, there are 5 blue marbles and 3 red, so there's a total of 8 marbles. And so to get a blue marble out of my first box, it's a 5 out of 8 chance. And so this would be 5 divided by 8. And I'm going to write the decimal of that. The decimal is 0.625. Alright, so the probability of getting a blue marble given I've got box 1 is a 62.5% chance. Alright, then you could do the red one, and I'm going to work it the same way. Alright, you could use the complement here, and you'll see that it is the complement. The probability of getting a red marble, well, there are 3 red marbles out of the total 8, so this would be 3 out of 8, or 0.375. You can read that, 0.375. And I'll do the and statements at the end. I'm going to fill out my tree first. Alright, so there's all of the different ways I can get red or blue given I've got box 1, and now I'm going to do box 2. So given I've got box 2, so the second box, so now I'm looking at box 2's numbers. So if I know I have box 2 in my hand, the probability of getting a blue marble is, well, there are 2 blues out of 5, and so this would be 2 out of 5, which the decimal of that is 0.4. And again, you could just use the complement. You could say this is going to be 0.6, but again, where it comes from is the probability of getting a red marble, given I've got box 2 in my hand, is there are 3 red marbles out of 5, so this would be 3 out of 5, which is 0.6. And there's the conditional probabilities based on my given events. Alright, then the last thing is the and statement, so multiply down the line. Alright, so the probability of getting a box 1 and a blue would be 0.5 times the 0.625, and I'm just going to write out, make sure you do not round, write out all 4 decimal places, so it's 3, 1, 2, 5. Alright, then box 1 and red comes out to be 0.1875, and if you add that up, that's 50% of the outcomes, because it's 50% of the cases that came from box 1. It should also be 50% of the cases that came from box 2. And so 0.5 times 0.4, well that one's just 0.2, and then 0.5 times 0.6 is 0.3, which again, that one's a little obvious that it's the 50% of the outcomes. Those are all of the outcomes where we've selected box 2, which are 50% of our outcomes. Of the box 2, 20% chance that you get box 2 in blue, 30% chance it's box 2 in red. And then again, those are all my outcomes, they add up to 1. Right, so there's the tree. Now I'm going to ask you questions based on the tree. The first few questions are going to be old questions. Mixed in with the old question is going to be the new question, the one that's base formula is 7-6. Alright, now to the questions. Once I've got the tree, I can answer. Alright, so the first one is to find the probability that a blue marble is selected given that box 1 was chosen. So this is a conditional. And so my rule of thumb is to always write the conditional out. Alright, this is a conditional that's on our tree. Alright, the probability that we have a blue marble selected, so probability that we chose blue, given we picked box 1. Well, the formula for the conditional probability is the probability I picked box 1. Up top would be the and statement, box 1 and blue. Which, this is one of the conditionals on my tree, right? The probability of getting box 1 is 0.5. The probability of getting box 1 and blue, if you go look at the tree, was 0.3125. That comes out, if you divide that out, 0.625. Which again, you could have figured that out was, well, that's the probability on my tree, right? That's this conditional probability. Given I've got box 1, the probability of getting a blue marble is that 0.625. And so you don't necessarily have to write out the formula. I just always do. It's just a good rule of thumb just to have, to double check myself. Alright, that's it. But if you just want to go straight from the tree to this answer, you can. So this is a conditional, but it's a conditional that I found for my tree. Alright, so it's one of the ones that was on my tree. Right? So it's given the first event, what's the chance I get the second event? Alright, next example. Find the probability of selecting a marble that is from box 1 in blue. Alright, so this is not a conditional. This is just, what's the probability of selecting a marble so that all of my marbles are at play? So this is out of all outcomes. What's the probability out of all outcomes? It's the case that it came from box 1 and is blue. So this is the probability that it's box 1 and blue. Well, that's one of the end results of the tree. That's the 1 and blue case. Right, which is this probability I have up here. So 0.3125. Right, now, it was based on a conditional. I used a conditional to find it. But this one is not. It's just out of all, right? I'm selecting any marble, right? Selecting a marble. All of them are at play in that case. If I select any marble from this experiment, what's the odds that it came from the first box and is blue? Right? Well, the odds are about 31% chance. Alright, next one. What's the probability of selecting... Oops. Let's use my highlighter, not my pen. What's the probability of selecting a blue marble? Right, so again, I'm selecting a blue marble. All blue marbles are at play. So this is the probability that I get a blue. Well, I have to find out, well, how many ways can I get blue? There's 2 ways to get blue. I can get box 1 and a blue marble out. Or box 2 and a blue marble. Right? Those are the 2 ways I get blue, and so I add up the 2 outcomes. So box 1 in blue was 0.3125, and I add up the case box 2 in blue, which was 0.2. So the probability, if I do this experiment, alright, run it all the way through, the chance that I get a blue marble, and the blue marble, since it's any blue marble, it can come from any of my boxes. So out of all of the blue marble options, the probability that I get a blue is 0.5125. So a little bit better than a 50% chance to get a blue marble. Which means there's a little less than a 50% chance to get a red marble. Alright, the last one. So this is going to be our new question. So this is the new type of question. Alright. If the marble selected is blue, so I've done the experiment and I have a blue marble sitting in my hand. Alright, so I'm holding a blue marble. So I know I got a blue out of the experiment. I want to know what's the chance that blue marble in my hand came from the first box. Well, this is the new type of conditional. This is the 7.6 Bayes type. I'm given the end result of my tree, the end result of my experiment. What's the chance that it came from a specific first result? In this case, the first result was box 1. Right, so set up the formula. So probability, right, that it came from the first box. Right, that's the probability I want to know. What's the chance that it's box 1 I selected my blue marble from? So what's the probability that it was box 1 given I had a blue marble? Alright, so again, 1 given I got blue. Well, the formula for that is I divide by my given. My given is I've got a blue marble in my hand, so that's what I know, right? I know it's blue. What I don't know is which box it came from. So I want to know, well, if I've got a blue marble, what's the probability it came from box 1? So up top is the box 1 in blue case. Which I actually have all those numbers already. So all of the ways I can get blue, well, that was this outcome here. So the odds of getting a blue marble was 0.5125, and then the probability of getting a blue marble that came from box 1. So out of all the ways to get blue, these are the chances that it came from box 1. The other outcomes would be box 2. Alright, so 0.3125. 0.3125. And again, don't round. Write them exactly. You don't want to round to the very end of the problem. Alright, so when you take your 0.3125 divided by your 0.5125, the odds that if you have a blue marble in your hand, that it came, so if you've done the experiment, the blue marble's sitting in your hand, the chance that that blue marble came from box 1 in this experiment is about a 61% chance. It's 0.698, so I'm just going to round to 61. Alright, so about a 61% chance the blue marble came from box 1. And so this is the new case. And all the other questions were old cases. And so now there's one more question I can ask you with trees. That's why usually you'll have a tree example. I'll ask you to set up a tree, and then I'll ask you 2 or 3 questions based on said tree. All right? And there'll be these types of questions that you'll be asked. Let's do this second example. And then I'm going to probably stop the video there, and then we'll do the other 2 examples on another video so that you can kind of break it apart and look at them at little sections at a time. All right, so example 2. So based on past experience, so this would be based on statistical relative frequency probabilities. The company knows that somebody who is experienced, so they've been working there for a while, a year or more, they'll only produce a defective item 1% of the time. So human error is only 1%. People with some experience means up to a year but not over a year. Have a little higher because they haven't worked there as long, so their defective rate's about 2.5. And then anybody who's new, meaning they've only been employed for less than a year, the new people tend to have a defective rate of 6%. And it should make sense. The longer you work, the fewer mistakes you'll make, right? The newer you are, tend to be higher mistakes. And those are conditional. So this is how you sort of recognize this is a conditional phase, right? This is not all people. This is just the experienced people, right? 1% is the experience. The 2.5 when they have some experience, not experiments. I keep wanting to say that. And then the new guys are 6%. Right? Those are conditional probabilities. It depends on how much experience you have. So the condition is your experience. The condition is your experience. Given a certain amount of experience, the odds of you producing a bad item is different. Alright, so I'm going to set up the tree. So again, it's based on conditional. So trees is where you put your conditionals in. Alright, so we've got our operators. Alright, the classification. As experience, some experience, and newbies. And then whether they're going to be a defective item or not. and then all outcomes. Alright, so there's 3 classifications, and so I'm just going to do E, S, and N. I've got experience, some experience, and new guys. Alright, so E means they've got experience, S means they have some experience, and N is the new people. Alright, and then they will produce some defective items, they'll produce some not defective items, and so on. So my D stands for defective, D prime is not defective. Defective, not defective, and then all my outcomes. So this would be the experienced guy made a bad item, the experienced guy did not make a bad item. The some experience made a bad item, the some experience did not make a bad item. And the new guys made a bad item, and the new guys did not make a bad item. Right, now fill it out. Alright, so there's the setup, now the fill out. Alright, so the first one is, well, what's the odds that an item was produced by each of my people? Alright, and that's the last line here. Experienced employees produce 60% of the items. Employees with some experience produce 30% of the items. The rest of the items are made by new people. So the odds that an experienced person made the item is 60%, because 60% of the items are made by them. And so this would be 0.6, right? You always write it as a decimal. Those with some experience produce 30%. Right? They're a little slower. They don't produce as much. And there's probably fewer of them. And the new guys produce the rest. Well, remember, this has to add up to all the items being made. So right now we've got 90% of the items being made between experienced and some experience, which means 1.1, which is 10%, are made by new people. And there should be less new people, and they're not as fast, probably. They don't make them as fast. And so there are my classifications. So 60% of the items are made by the experience, 30% by the some, and 10 by the new people. Right? Now what's the odds that those that they produce are good or bad? Alright, so these are my conditionals. Given that an item was made by the experienced guy, only 1% of them will come out bad. So the odds that it comes out bad, defective, is 1%. Now be careful, remember 1% is 0.01. Don't forget the 0.1. Which means 99% of them are good. Right? 99% are fine. Alright, so we've got the some experience, so same idea. The some experience guys will produce a defective item 2.5% of the time. So given the item was produced by somebody with some experience, that's probability is 0.25. And so make sure you're careful. The 0.25 is 0.025. So don't forget that it's really easy to miss that 0. Which means the probability that those with some experience produce a non-defective item is 97.5, 0.97, right? That adds up to 1. So you take this minus 1, 0.975. Right, then the new people, right? New people will produce a bad item 6% of the time. Right, so 6% is 0.06. And so they don't produce a bad item 94% of the time. Right? And so there's my conditionals, where half of them were given to me, the defective ones were given to me in the problem, and so I had to figure out the non-defective rates. Alright, then we multiply to get to the end, and make sure you're careful, do all of these exact, multiply down the line exactly. So 0.6 times 0.01 is 0.006, right? Exactly. 0.6 times 0.99, 0.594, there's 60% of the items. These are the ones produced by the experienced guys. They make 60 of them. 59.4 are fine. 0.6 are bad. Right, now the some experience. 0.3 and this one again, make sure you're careful. It's 0075, and don't round, leave it exactly 0075. And then this is 3 times 0.975, 0.2925. Again, leave it exact. 2925. Alright, then the new guys, 0.1 times 0.6, so 0.006. Now, the new people produce the same amount of bad items as the experienced, but remember, they're producing a lot fewer. They're only producing 10%. 10% of theirs comes out to the same. These guys are producing 60%. Right, so keep that in mind when you're thinking about these numbers. All right, then the last one is 0.1 times 0.94, which is 0.094. So make sure you're careful. These are kind of long and big, and so make sure you're very careful when you're typing these or writing these down, that you've got those zeros in the right place. All right, and there's my tree. Which then I ask you about 4 or 5 questions based on this tree, and so that's the next. So hopefully you've got the tree. There's the tree. Hope you got it written out in your notes. And now I'm going to go to the questions. Alright, find the probability that a randomly selected employee is new and not producing a defective item. So this is sort of the phrase that's important. Where am I selecting from? So I'm randomly selecting an employee, meaning all employees are at play. Out of all my employees, if I select one of them, or if I pick one of them, what's the probability they're a new guy and they did not produce a defective item? So this is one of my outcomes at the end. Probability that they're new and the items are not defective. Well, that's this case on my tree. 0.094. So about 9.4% of the items were produced by the new people and non-defective. Alright, next one. Probability that a randomly selected employee with some experience will not produce a defective item. Alright, so again, this one's different. The difference is very subtle, but there's this little extra here on this highlighted part. These were all employees. This is not all employees. I'm looking at only those with some experience. So I'm ignoring the new guys and I'm ignoring the experienced guys. I'm narrowing it down to just those with some experience. So given they have some experience, what's the probability they do not produce a defective item? Alright, so probability they are not getting a defective item given it's an employee with some experience. This is actually one of the ones on the tree, but I'm going to write out the formula because I think it's just a good rule of thumb to write out the formula. So the formula is, we divide by the probability they have some experience. Probability they have some experience. Up top is the and statement. They have some experience and the item's non-defective. Probability they had some experience was 0.3. Probability they had some experience and the item's not defective was the 0.2925. And then divide that out, and it comes out to 0.975. Which again, you didn't necessarily had to fill the formula out. If you recognize this is a probability from my tree. Given they have some experience, the probability that they will not produce a defective item, well, that's this probability here, right? The 0.975 is the probability that if they have some experience, if they're an employee with some experience, they don't produce a defective item 97.5% of the time. Alright, so again, that's on my tree. Next one, which again, apparently my lettering was doubled up again, so this is the second B. Find the probability that a randomly selected item will be defective. So again, randomly selecting an item, meaning out of all of my items, right, all of the considered items, so everybody's under consideration, all outcome, what's the odds I have a defective item? Probability it's defective. Well, there's 3 ways to get a defective item. Right? Either the experienced guy gave me a defective item, or the some experienced guy gave me a defective item, or the new guy gave me a defective item. And I add up all of those outcomes. Alright, so the probability the experienced guy had a defective item was 0.006. Some experience, remember that one, 0.0075. And then the new guys was the same as the experienced guys, 0.006. Alright, I add up all of, so again, those are all of the defective items by the experienced guy, some experienced guy, or the new guys. And so all of the defective items comes out to 0.0195. Alright, so probability that you have a defective item is a little bit less than a 2% chance, right? 1.95% chance that it's defective. And then again, the odds that it's from each of those employee types are separate. The last one. Find the probability that a particular defective item was produced by a new operator. Okay, so again, I'm not looking at the difference between this one and the previous one is there's a randomly selected item, meaning all items can be picked. This one's not all items. Right? It's looking at only those items that are defective. So given I've got a defective item in my hand, right, I've got a bad item, I want to know what's the chance that that bad item was produced by the new guys. So this is a condition. Probability that it was a new operator given I've got a defective item. So we divide by the probability it was defective, and up top is the AND statement. Probability it was the new guy that made the defective item. So this is the new case. This is the 7-6 outcome where I know the end result of my tree. What's the probability it was one of my beginning people that got me there? And specifically, it was the new guy that got me to my defective item. Which, I've got my answers up here already. This is the probability that it was defective, which were all the end outcomes where it was defective. And so I divide by that, 0.0195. And then up top is, well, out of all of the defective items, right, this represents all of my defective items, what's the chance that it was the new guy? Well, out of all my defective items, the new guy had this chance, 0.006. Right, so I take my 0.006 divided by my 0.0195 to get my actual answer, which is 0.308. Alright, so the probability that an item was produced, a defective item, probability that given the item was defective, it was produced by a new operator, was about a 30% chance. Right, 30.8% chance. Alright, and so we're just going to practice a few more of those. So I'm going to stop this video here, kind of give you these in bite size. And so the next video I'm going to pick up just a few more examples and then we're done. We're done with Chapter 7. Alright, so one more probably video just practicing these tree cases.